Okay, now a common thing you see with a two-dimensional array is a nested for loop. So that's a very, very common thing to do. So let's say, for example, that I need to figure out what the average score is per student. So I'm going to start this guy, and I'm going to say I need something to sum these guys up. So I'm going to do double sum. Okay. And then I'm going to start with just a plain old for loop. So I'm going to say for, and for God's sake, don't pick row and column or X and Y. Pick something that makes sense. So in this particular case, this is student less than num student. See how when you do it this way, it's practically impossible to get the axes wrong? I mean, just by looking at it, isn't it fairly obvious that you know, student belongs to with the num student guy? Yeah, just kind of makes sense. So let's just do that again. So now I'm going to say for int quizzes, or quiz, and then quiz is less than num quiz. And again, isn't that fairly obvious which one we're talking about? And then quiz plus plus. Whoa. Okay. Oh, man. Behave. Okay, so now I have a nested for loop, a for loop inside a for loop, and I very carefully designed it so that I can run through all the students and all the quizzes, right? Kind of makes sense? So now what I need to do is just sum up all of the things that I see, right? All right, so let's do sum is equal to, I'm going to go ahead and use this little cool thing, and then I'm going to say grades. Now, what's the x-axis? Is it the students, or is it the quiz? Well, go up and look on line 39. Isn't that nice that we actually have words there rather than having to guess? So it's fairly obvious that this is going to be student first, followed by quiz. Okay? All right. Actually, I kind of sort of needed that guy down here, but that's beside the point. Okay. So, all right, so now that I've summed this together, then I want to spit out what the average is, okay? Now, what am I doing? Am I doing the average per quiz or average per student? What am I doing? In other words, am I summing up all of the scores for a particular student, or am I figuring out what the score is for a particular quiz? Which is it? Well, the way you answer the question is, what is the outer loop? If the outer loop is students, then I'm doing it per student. If the outer loop is quiz, then I'm doing it per quiz. Okay, is this making sense? This is kind of a fundamental thing that you really kind of need to be paying attention to. All right, so I'm going to go here and say double AVG is equal to sum divided by. Now, what am I dividing by? Ooh, this is a good one. Am I dividing by the number of quizzes, or am I dividing by the... So if the inner loop is quizzes, right, then I need to be dividing by the number of quizzes. Okay, cool. So this is for every one student. So let's just display that, okay? Actually, I'm not, because I don't have any, I don't have any data in this thing at all, okay? So just bear with me. So I already know what the answer is going to be. It's going to be 0, but that's beside the point. So let's just pretend. So I'm going to say et display, and I'm going to say append, and I'm going to say student number, student, average quiz is AVG. Okay, is this making sense? How do you determine what goes in the outer loop and which one goes in the inner loop? And what am I dividing by? Yeah, those are fundamental things you need to be paying attention to. So if I wanted the average per quiz, what would I do? Well, I'd put the quiz on the outside, student on the inside. I would change that instead of saying student number, it would be quiz number, right? And then be divided by the number of students, right? Okay, cool. So, I kind of mentioned on page 389 that we have an exception if you overrun a particular array, which is why I use less than here, not less than or equal to, because if I did less than or equal to, it would definitely blow up. Okay, cool. All right. So, let's move on. So on page 389, they start talking about the Arraylist guy. So the Arraylist guy is kind of an interesting add-on. It's sort of like an array, kind of, sort of, all like an array, but it has some extra interesting features. Now the array is dumb as rocks. It doesn't actually allow you to do hardly anything. Now let's contrast that with what an array list can do for you. All right, so an array list. I don't need to know in advance how big the guy is. For all arrays, I need to be able to say, okay, I'm going to have 100 students, so I need to put 100 in there. But for an array list, it's like, I don't know, we'll figure it out later. Which is pretty doggone cool, right? And the other one is, it'll automatically resize itself when it needs to. If I start adding to an array list and I run out, and like in the array world, if I told it was 100 and I put 101, it'll break. But if I start off with 100 on an array list and I go to 101, it goes, no problem. Oh, I'll just increase my size to match that. Don't worry about it. It won't even tell you that you made a mistake because technically you didn't. With an array list, I can insert in the middle of, here's an array. I can pop it apart, put a new value in there, doink, or take something out in the middle and it'll collapse. You can't do that with an array. If I wanted to add something in the middle of the array, I'd have to have something that would physically copy all the cells over and put one in, or take one out and then copy the cells over again. Kind of a pain. And then, of course, it has a bunch of cool methods for like clearing and doing all sorts of things, like searching and other kind of cool features. So those are really good reasons for using an array list. So you might be wondering, if the array list is all that good, why do we even have the older array thing? In Python, that's basically what they have. Python doesn't even have support for the older array. It's just array list and that's it. Well, the reason is the array list is actually the most efficient way to have a group of things together because it's stored contiguously. In other words, if you build an array of 100 items, you're guaranteed that all 100 of them are in one chunk of memory, not like half of them over here and half of them over there. So when it comes time to go through and say, okay, I want this one, this one, this one, this one, this one, this one, it's trivial for the machine to figure out where things are because they're guaranteed to be stored in one location. Now, an array list could start over here and be half a third of it over here and a third of it over there. So it is dang convenient from a programmer's point of view, but it is not as efficient, not even close. Okay, so I'm going to do one here. So I'm going to build me an array list. So array list, but the angle brackets, and then you tell it what it's going to store. Like I want to store a string. Okay, this is very similar, somewhat analogous to the array where you had to tell it what the data type is. Okay, but here you told it what the data type is right at the kind of beginning. Since this guy is, anyway, he's just different. So how about names is equal to new array list. Now I typically put this angle bracket in here twice. In Java, that's kind of a not necessarily a requirement. You don't actually have to put. They're smart enough to say, well, dude, look, you already put the data type in here once. There's no need to put the data type in there a second time. But other languages do prefer that technique. So just for consistency, when I move from one language to another, that's the way I do it. Okay, so this built me an array, and I didn't have to tell it how big it was. So my array list could be something like names.add, and then I say, Bob. Well, if I could spell Bob. And then I could just do another one, just keep going, right? Names add Sally, since that's the names that I always use, don't I? Okay, and I can just keep going, right? Boom, 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 boom. And so if I wanted to add something in between Bob and Sally, do you think maybe there's something called like insert at or something like that, where you actually tell it the location? Yeah, kind of cool. Okay. There is one really bizarre thing with Java. And I've yet to hear a decent explanation of why this is. But the array list cannot use the plain old reference types. I said it wrong. Value types. So I cannot do an array list like this. It basically says, no, I'm sorry, primitive types you can't do that with. Now, there's an interesting way around it. Remember that in Java, primitive types have a wrapper class. Okay, so all of the primitive, well, not all, but the primitive types for numbers also have. So instead of using the lowercase I, if I said integer, it would go, oh, okay, I'm happy with that. So here's the rule, not that it makes any sense. By the way, the book is wrong. I'm just telling you. On page 389 and 390, they say, well, you can use an array list for any type. No, you can't. Not with primitives. But you can use the wrapper, which is a reference type. Now that's just an oddity of how Java does an array list. Okay, so just like make a note of it that I can't use primitives. Okay. All right. Another thing you can do is you can have an array list with very complex types. Like for example, I stole the employee and employee exempt files from Chapter 9, I think. So I could go in here and say array list employee, and I'm gonna call this one imp list. Oh, dang it. Helps if you spell it right. And then I go in here and I say, new array list. And of course, I am going to go in here and put this in here, although technically it's not required. Okay, so this is a very complex thing, right? So why not? Let's go ahead and, just like we added Bob and Sally, let's do this. Let's add us an employee. So employee, I don't know, we'll call him imp1. Dang it. Imp1 is equal to new employee. And then okay, so that would be something like, oh, doggone it, come on. Bob Smith. And the type is going to be employee. Let's make him an engineer. Okay, so I built me an engineer, and I'm going to add him to my list, right? No big deal. So imp list add imp1. There we go. That worked out pretty cool. So, these array list things are pretty doggone cool. Now, let's do an enhanced for loop. That's on page 391. An enhanced for loop would be one of those things that allow you to spit through one of these array lists or an array, either one, a lot faster. Now, I'll explain. Let's just do one the normal way, where I would say for int equals like something like this, and I would say, int I is equal to 0 and I is less than the length of the array list would be names dot size. Is it length or is it size? And then I plus plus like this. I mean, you could do that, right? And then I could say I want to display what out. Display append. Okay, we're coming up on the 15 minutes mark. You guys know how this works.